Have you ever wondered how such a heavy aircraft flies in the air? When a plane runs on the runway, the real game begins in its wings. The wings divide the air into two parts. The air above moves faster, the air below slower. And this creates an invisible force that lifts the entire aircraft upward. But the story doesn't end here. One of Newton's laws says, every action has an equal reaction. When the wings push the air downward, the air pushes the aircraft upward. And the engine? It throws the aircraft forward with so much force that even gravity gives up. But if the speed decreases, then lift disappears, and the plane can fall. Meaning, flight is not just a machine, it is the most beautiful game of physics. When you see an aircraft flying in the sky, have you ever asked yourself, how is it actually flying? Is it happening by magic, or is there some science behind it that our eyes cannot see? Such a heavy metal aircraft carrying thousands of people, how does it stay in the air? Is the air really that powerful? Or has humanity learned how to use air? And if air is everything, then why doesn't everything fly? Today we won't just understand these questions, we will feel them. Now the first question, what actually lifts a plane upward? Does the engine throw it upward, or do the wings perform some magic? The truth is, there is no single thing behind flight, but a balance of multiple forces. And without understanding this system, you can never understand how a plane flies. So first, we need to understand the four forces acting on every flying aircraft. The first force, weight, meaning gravity. This is the same force that pulls everything downward. When you throw a stone upward, it goes up for a moment, but then falls back down. Why? Because gravity pulls it back. Now imagine a plane weighing thousands of kilograms. How much force gravity must be applying on it? Meaning if the plane has to fly, it must generate more force than gravity. And this is where the real game begins. The second force, lift. This is the force that lifts the plane upward. But the question is, where does this lift come from? Can air really be so powerful that it can lift a heavy aircraft? Let's understand this. When the plane moves forward, its wings cut through the air. But wings are not ordinary. Their shape is specially designed, slightly curved on top and relatively flat below. Now when air hits these wings, it splits into two parts. One part goes over the wing, and the other goes below. But something interesting happens here. The air going above has to travel a longer path, and the air below a shorter one. And because of this, the air above moves faster, and the air below slightly slower. Now a simple rule of physics says, where air moves faster, pressure becomes lower. And where air moves slower, pressure becomes higher, meaning higher pressure below the wing and lower above. Now what does this pressure difference do? The higher pressure below pushes the wing upward, and this force is called lift. Meaning, the air does not lift the plane, but the pressure difference in the air pushes it upward. But the story is still not over, because lift alone cannot make a plane fly. It also needs to move forward. And here comes the third force, thrust, meaning the force that pushes the plane forward. The engines throw air backward at high speed, and Newton's rule says every action has an equal and opposite reaction. Meaning if air goes backward, the plane moves forward. And as the plane's speed increases, the speed of air flowing above and below the wings also increases, which makes lift even stronger. Now the fourth force, drag. This is the force that tries to stop the plane. When the plane moves forward in air, the air pulls it backward. More speed, more drag. That's why planes are given a smooth and aerodynamic shape, so they can cut through air easily. Now understand the whole game. On one side, gravity is pulling the plane down. On the other side, lift is pushing it up. On one side, thrust is moving it forward, and on the other side, drag is stopping it. And when all four forces come into perfect balance, then a massive aircraft appears to float in the sky. But here is a twist. If at any moment this balance breaks, like if speed decreases, then lift will decrease, and the plane will start falling. Meaning flight is not just about force, it is a story of balance, and this balance runs on the most beautiful principles of physics. Now we have reached a level where surface-level understanding ends, and real physics begins. Because the truth is, a plane does not just cut through air, it controls the air. And the biggest tool of this control is its wing. But this time, we won't understand the wing by its shape, but by airflow behavior. When the plane moves forward, the air in front doesn't just move away. It is forced to change its path, and this change is where the whole game begins. As soon as airflow reaches the wing, it starts accelerating. But this acceleration is not just above, it changes the entire surrounding pressure field. Now something very important happens. Low pressure above the wing is not just because air is moving fast, but because the wing pulls the airflow toward itself, meaning air particles passing over the wing don't just pass, their path bends. And this bending is called curved streamline motion. Now, as airflow follows a curve, it has to change direction. And changing direction requires force. This force is given by the wing. But physics says, if the wing applies force on air, then air will push the wing with equal force. And this push becomes lift. Now understand this deeper. A low-pressure zone forms above the wing, and a relatively high-pressure zone below. But these zones are not static. They continuously move with the airflow, meaning the plane creates an invisible pressure field around itself, which keeps it sustained in air. Now let's add another layer, angle of attack. But don't think of it as a simple tilt. It is actually a control parameter of airflow interaction. When the wing tilts slightly upward, it deflects airflow downward more aggressively. And the more air goes downward, the more reaction force comes upward. But another thing happens. The low pressure above becomes even stronger, meaning two effects work together, suction above and push below. And together they multiply lift. But this system is very sensitive. If the angle increases gradually, lift also increases gradually. But a point comes where airflow cannot stay smooth. It starts separating from the wing surface. This is called flow separation. As soon as airflow breaks, the pressure field collapses, and lift suddenly drops so much that the plane can lose control, meaning the problem is not just speed, but airflow structure. Now imagine, the plane is perfectly stable in air, airflow is smooth, pressure zones are balanced, but suddenly the pilot increases the angle too much. What will happen? The wing will fail to control air, airflow will break, lift will drop, and the plane will become unstable. To recover, the pilot has to reduce the angle so airflow can attach again. Now understand another hidden concept, air inertia. Air particles don't change direction instantly. They need time and space. That's why wings are designed. So airflow follows a gradual curve. If the curve is too sharp, airflow will break and lift will vanish. That's why in real engineering, wing shape, angle, speed, all three are optimized together. Now see the full picture. A plane does not fly because it is light. It flies because it bends the air according to itself, changes its path, and the reaction of that change lifts it into the sky. Meaning the real secret of flight is not in defeating air, but in controlling it. By now you understand how a plane rises, how it controls airflow, how it fights drag, and how it maintains balance every second. But now the most important question, can this system ever fail? And if it does, what will happen? Because the truth is, as beautiful as flight looks, it is an extremely sensitive system. And this entire system depends on the balance of physics. If this balance breaks even slightly, the result can be dangerous. First, understand speed failure. If the plane's speed decreases, airflow becomes weak. Weak airflow, less lift. And as soon as lift becomes less than weight, the plane will start descending. But the biggest danger here is stall. This is the moment when the wing cannot hold airflow. Airflow breaks, the pressure field collapses, and lift suddenly drops so much that the plane can lose control, meaning the plane can become instantly unstable. Now the second danger, angle. If the pilot increases the angle too much, initially lift increases, but after a point, airflow separates and the plane becomes unstable, meaning trying to gain more lift can backfire. Now the third factor, drag imbalance. If drag suddenly increases due to bad weather or wrong configuration, then thrust cannot compensate and the plane will lose speed, meaning indirectly, drag can also cause a crash. Now coming to engine failure. If the engine stops, will the plane fall immediately? No. The plane can glide for some time, but without thrust, speed will gradually decrease. And if not controlled properly, lift cannot be maintained, meaning engine failure is not an immediate crash, but wrong handling can make it one. Now another hidden danger, weather. Air is not always smooth. Sometimes turbulence occurs. Vertical air currents form, which can push the plane up or down. If these forces are strong, they can disturb the aircraft's balance. That's why pilots use weather radar. Now another critical thing, weight distribution. If the plane's weight is not properly balanced, its center of gravity shifts, which makes control difficult. The plane becomes unstable, and in extreme cases, this can also cause accidents. Now imagine, all these factors together, speed, angle, airflow, drag, weather, all changing every second, and the Pilot Plus system are continuously managing them. Meaning flight is a constant calculation, where physics is making decisions every moment. Now one final truth, planes do not crash because they are weak. They crash because the balance of physics breaks. And when this balance breaks, the system has very little time to recover. But this is where engineering plays its role. Modern aircraft are so advanced that they have multiple safety systems, backup systems, auto-correction, warning systems. So the pilot gets signals in advance and can correct mistakes. Meaning the entire aviation industry is built on one thing, understanding physics and ensuring it never fails. Now, if you look at the whole journey, you will understand that flight is not a miracle. It is the result of understanding nature's rules and using them in our favor. And this is the real power of science, which turns even air into a support system. But remember, where there is balance, there is stability. And where balance breaks, danger begins. Meaning, every plane flying in the sky is not just metal and engines, but an example of perfect harmony of physics. And this harmony keeps it safe. And if it breaks, it can bring it down as well.